do have a special treat. It's not about doses, it's not about regimens, but it's about a bugaboo that a lot of us have. It's those questions about infection control. And who better to bring you than the guy that everyone turns to, the WHO. He's a lead senior service public health engineer at CDC. Sure, something like that, global health. Yeah, a captain? Retired captain, right. But Paul Jensen is our friend, and he's TB's friend as well, and he's going to help lead the revision of the infection control book for Curry, and he is an engineer, so someone we really need to explain some of these things to us. And so here for your listening pleasure and to close the day is Paul Jensen.
Okie dokie. So the first thing is, I'm from CDC. Very few of these slides are CDC policy, because what we're talking about is things that we should consider changing in future policies. So I'm not saying CDC says this, but I think it's something to think about. But first, there are many, 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 many women here, so happy International Women's Day. And on behalf of the men, we know we can't survive without you. Okay, so I've got a short video here, because what this does is this shows me, whoa, stop. Well, okay, watch it, then I'll tell you what happens. What happened there? When we talk about infection control, and we talk about TB infection control, what are we doing? We're forgetting everything else. So we have tunnel vision. So don't have tunnel vision when we talk about infection control. So anyway, the title of this talk is something about TB infection control. But my first question is, do we know that the patient or person, because there aren't always patients, has TB? We don't know their status. So what we should think about is standard precautions or airborne precautions in all settings. It doesn't mean wear a respirator at all times, but think about airborne precautions. Now, there are a bunch of references. I forget where this one came from. Oh, wrong button. Let me see if I can do this. Doop. I don't have my glasses on. I know where they are, but which button says pointer? Oh, the bottom one. I thought the red one. Red pointer is not the red button. Okay, there we go. Thank you. So there's a Curry book that we were just talking about. We've got the 95 guidelines, which are the official CDC policies. I'm going to, in a few places, mention some WHO documents. This one's a oldie, moldy one from '99, which is the first set of guidelines they had for infection control for TB. The one on the left deals with, it's an appendix to the document on the left, but the one on the right is deals with HIV care and treatment settings. 2009, they came out with a policy for national and subnational folks. I'm not sure what subnational means. And then they also came out with a document for natural ventilation. So I'm going to kind of hint at a few of these things as we go through. Now, I started my professional life in the Coast Guard, then went to NIOSH, which is part of CDC, and then to the TB program. The reason I'm saying this is when I first started in the Coast Guard, we had a different hierarchy of control. We had this silly upside-down pyramid, but when we talked about protecting workers, protecting people, what we were trying to do is eliminate the hazard. So what we need to do is eliminate TB patients, right? Now you're laughing, but we need to be serious, because if we eliminate TB patients, then we don't have to worry about all this other stuff. So our goal should be elimination. but not necessarily by eliminating patients. The next thing is substitution. So next time somebody calls you for a TB appointment, say, no, I want a healthy patient, right? So this hierarchy doesn't quite work, but they talk about engineering controls, administrative controls, and PPE, which is what you hear about in the traditional TB infection control or the general infection control stuff. But let's take a look here. What does this say? I can't read it. The beginning part's really the hardest. The top of this upside-down pyramid is really the hardest to implement. And PPE, I personally think is the easiest, but some don't. But it could be PPE or administrative controls are the easiest. Now let's take a look on the right-hand side. Which are the most effective? The top of this upside-down pyramid, or is that the bottom? I guess the highest part of this upside-down pyramid can be the most effective. And when we talk about respirators, I'll show you why it might be the least effective. So now let's go to CDC slide set. Chuck talked about the CDC slide sets. And this is the only slide that's from that slide set, where they talk about administrative controls on top of the upside-down pyramid. Then they've got your environmental controls. We used to call them engineering, but we needed to change the word because we had new guidelines. And then we've got respiratory protection. Most of the guidelines say personal respiratory protection. What's the difference between personal respiratory protection and respiratory protection? Well, do you put a respirator on a horse? No, so it sort of implies, so we're trying to shorten it so it fits in the slides. We're just going to call it respiratory protection in the future. But in reality, if you take a look at the rest of the world, they do a pyramid like this. Does it matter? No. But let's stick with this type of pyramid with the base is administrative controls, then environmental controls, and then respiratory protection. But WHO, in their wisdom in 2009, said, well, we have to divide administrative controls into administrative and managerial controls. What's the difference between administrative controls and between managerial controls and administrative controls? Well, they just arbitrarily said, okay, things related to policies are managerial, and things that you actually do are administrative. So separation would be administrative, surveillance would be managerial. So you may in some documents see this, but in the newest revision of the WHO guidelines, we're getting rid of this. But it's just to warn you. But then you have the same hierarchy. So is that a good hierarchy? Well, let's take a look. Here's something that I had come up with, which I'm going to show you, there's another version of it. But you sort of have the administrative controls, environmental controls, and respiratory protection, all on one side. So it's a hierarchy on the left. But you're not going to apply the same control to the worker, the patient, and the rest of the facility. So when I teach assessments, we talk about, okay, what kinds of administrative controls would you have for the patient? What kinds of administrative controls for the worker? So it helps you better understand or evaluate a facility. But now I want to show you, that's not really a pyramid, I guess it's a set of steps. This is the newest concept that I've got to talk about, because what's missing in environmental controls? What's missing in respiratory protection? If we take a look, if you have environmental controls, you need the policies, procedures, maintenance, money, and everything else to keep those operating. If you require respirators, you need a respirator program, be training, fit testing, medical clearance, and all that stuff. So when we take a look at this, it's, yes, there's a hierarchy, but administrative controls isn't just at the base of it. Administrative controls are throughout the whole process. This one's new for you, isn't it? Woo! So what is infection prevention and control? This is just sort of a couple of review slides. We always know it's transmission of the patient to others. What we don't always think about is what if your worker has TB, or a visitor, or somebody else? So when we talk about it, we want to make sure that we emphasize not just the occupational side, which most guidelines do, but talk about the holistic approach. Now, the next 3 slides I'm going to go through really quick because this is just verbatim from the 2005 guidelines. But when we take a look at administrative controls, a few of the important points are make sure somebody's assigned responsibility. What does responsibility mean? You're fired if you don't do it. But is that what you really need? You need the authority to make change. That's not always emphasized. Have a written plan. And then there's a bunch more junk. And a little more junk. But the idea is there are many steps to it, but what are the important steps? At an international conference, and this is more international than the US, there's something called the FAST strategy. And what we're trying to do is simplify the concept of administrative controls into something that people could handle a piece, not necessarily everything in the whole list of administrative controls, but what are some critical elements that they can attack now and then add some of the other ones. Because many of the places that I go have 0 infection control. So we had to start somewhere. So we came up with this acronym of find cases actively, separate those cases, and get them on effective treatment. So really that's what TB control is all about. And if you do this, then you'll fill out that top bar of that first hierarchy of eliminating. If you find them, separate them to reduce transmission, and then put them on effective treatment. There were some questions. I also was given a set of questions, but I kind of threw them into the presentation. But there's a question about NAAs and how do they relate to infection control. If we take a look at airborne infection isolation, it's used or may be used as one of the tools, and I'll talk about that in a future slide, of when can you release somebody from airborne isolation. You can use it for ruling out TB. We know that. For discontinuation, the 2005 guidelines say base it on microscopy. When we take a look at what FDA and CDC has come out with the joint statement, is with 1 or 2 expert MTB, RIF results, you can release them from isolation. That's the same one. There's some questions about infectiousness. And here's a specific example. This is a question for you to see if anybody's still awake. If you're sputum smear negative, gene expert positive, culture positive, is that patient more infectious or less infectious than a patient that's smear negative, gene expert negative, culture positive? And the real answer is probably more. There's not strong data to support an answer. But from looking at studies and trying to extract from the limited data that's in a written publication, you can't say exactly, but they sort of imply that the one would be more infectious than the other. So does expert tell us anything about infectiousness? The answer is yes. We just don't know exactly what it tells us. Another slide about infectiousness this is a study that was done with a consortium of CDC, Harvard, University of Pretoria, and Medical Research Council of South Africa at an airborne infection research facility in Witbank, South Africa. We had a number of MDR-TB patients. They were put on treatment. We had the air from those patient rooms go to animal rooms, and we used guinea pigs to sample the air. And what we found there was this model showed that effective treatment appears to render MDR-TB patients rapidly non-infectious. Now, non-infectious may be a little too strong of a term. It's probably less infectious based on the limited number of guinea pigs. So we don't know for sure what that limit of detection is. And we had a long discussion about that, but majority opinion was to put non-infectious in the paper. and the reviewers accepted it. I don't know if any reviewers were here. But it also says we need some more studies which haven't been done yet. Let's talk about cough etiquette for a minute. How effective are surgical masks at preventing small particles, or TB, from being aerosolized? It's going to be a multiple guess. Okay? 0, 25, 50, 75. And my grandmother taught me never to say always or never, so we'll cross out 0 and 100. Majority think 25? Anybody think 50? Anybody think 75? Oh, good. You're all wrong. There's a study done at University of Cincinnati in an aerosol chamber, and they had a mannequin with a coughing machine, not just a breathing machine, but a coughing machine. They aerosolized the vaccine strain of B. anthracis. They tested endospores. They found that essentially reduced the amount emitted by 58%. How many said 50%? Very good. When we took a look at vegetative cells, it was even higher, 71%. How many said 75? Very good. How many said 25? Okay. Well, then at the same air facility, we did a similar study. We had patients about 7 o'clock in the morning, right after breakfast, put on surgical masks. Lived in the hospital all day long, though they take it off to occasionally smoke and do other things. And then at 8 o'clock at night, we would switch the air to the other animal colony. So we were trying to take a look at how effective are surgical masks on real patients. So what we found here was 56% effective. So how effective is that 2-penny surgical mask in helping reduce transmission? Very effective. So what we need to do is convince, and these are all data since 2005, we need to convince people how effective something this simple is at reducing transmission. The other thing we have to do is think of cough etiquette as not just because you have TB, it's good public health practice. It's also important to not always say, though you'll hear me today because that's what Lisa told me to talk about was TB infection control. But when we take a look at general infection control, we're really talking about airborne infection control. So it's nothing new to the infection control people. It's really airborne infection control that we're talking about. And what we have to also understand is risk. We heard about it earlier today, but is the risk the same everywhere in the facility? No. Is the risk from patient to patient the same? No. So let me show you a short video about risk, and you tell me if the risk has changed. You ready? Crazy guy. It's not over. What happened to risk? If we take a look at studies, these are really for international studies, medium. If we take a look at studies by department, compare the incidence of TB among care workers and compare to the population, there's a huge difference. Take a look at outpatient facilities, 4 to 11. Emergency departments, 26 to 31. Significant. These aren't TB facilities. These are just general health facilities. So where's the risk? The risk is really with the undiagnosed patient. How about labs? What do you see here on the bottom? Does that scare you? Well, let's take a look at labs. Okay, this is a study from Korea. It's a relatively small study, but take a look at microscopy technicians. What do? They take the sputum, spread it on a slide, not a whole lot of chance for aerosolization. So their incidence rate ratio is relatively low. Culture technicians, what do? An auger. However, at they might manipulate that again. So if you take a look, it's greater than 1, goes up to 35. What do DST technicians do? They only deal with high concentrations. They deal with cultures and transferring cultures and use these magic boxes that we'll talk about in a few minutes and look at their risk. So even within a laboratory or the same department, you may have different levels of risk. So that's what we need to look for when we're doing assessments and determining what we need to implement, because we don't need to implement everything everywhere. And when we talk about patients, this is sort of the guiding light, Florence Nightingale. How many nurses? Very good. A fellow nurse. Essentially says, we don't want people to go in the hospital with something and come out sicker than they went in. Talk about environmental controls for a few minutes. This one keeps dying. Yep. You're welcome. Okay. Woo. Is that better? Okay. I almost did the one leg thing, but when we talk about environmental controls, we often think about ventilation. We've got mechanical ventilation. Historically, when we talk about mechanical ventilation, we're talking about dilution ventilation. I'll talk about that again in the future. If you talk about a clean room, you know what a clean room is? A clean room is something where you may deal with compounding of pharmaceuticals. You may deal with making electronics type things where you have clean air, HEPA filter air going from one side of the room, slow velocity to the other side of the room. And then I'm going to explain to you what displacement ventilation is, which is a newer type of ventilation. It's not new, it's been around for many, many years, but it's more recently been applied. And I'll talk briefly about natural ventilation. The other big environmental control that has a little bit of new information is UVGI. And then I don't have a slide about room air cleaners, but how effective are room air cleaners? Very effective? Not effective? Or no clue? Depends. It depends is the answer. I would say that 90%, and it could be higher, of the room air cleaners are not doing anything for you. They can make a smell in your room, they can make a noise, they can make your electric meter go round and round and round. But what we need to understand with room air cleaners is what is it's called clean air delivery rate. The manufacturer may come in and say, here's a pamphlet that says it's 600 cubic feet per minute. Well, what's the actual flow rate through the unit? That 600 cubic feet per minute is probably without the filter in it. So you put a filter in, it gets down to 200. Well, they didn't put a HEPA filter in it, they put a 90% filter in it. So instead of 200, you got 180 cubic feet per minute. What's the average volume of a room? We'll do easy math. No paper, no pencil, no calculator. It's a 10-foot by 10-foot room. What's that? 100. Now we're going to give it a 10-foot ceiling. So what's that? 1,000. So what is 180 into 1,000? Less than 5. So if we just think of and that's a good air cleaner. So if we start to think about room air cleaners, it may be fine, but you might need 4 or 5 in your room. And is that feasible? Probably not. Yeah. One thing that often happens is there's really not proper commissioning of environmental controls. And what do I mean by that? You know, you may have a new renovation, you see nice grills on the ceiling, you might hear a little bit of noise, and you say, we've got perfect ventilation. But we have to understand looks are not everything. What's your best tool for evaluating ventilation? Pardon me? A lighter? That's a little too technical for me. You can use a paper towel on your door. That's too technical. Stand up, Lisa. I need one. Okay? We both have one. What's this? Mine's much bigger. But you go into a room, and if you notice odors, what do you think the ventilation rate is? Good or not so good? Right. So your number one clue is really odors. So you need to calibrate your nose. If you can't smell, you got to find another job. But in many places, you can tell, you walk into a room, it feels humid or sticky. You have either body odors or chemical odors. Well, the ventilation's not working. Period. You don't have to take measurements or anything. And just because you hear it or you see a blue light or something like that, it doesn't necessarily mean it's working properly. Eventually, you need to get a qualified person with calibrated equipment to check it out, but you can at least identify if there's a problem. And quite often, engineers, architects, it's more the architects that do it, but architects will show you a drawing that has arrows on it. It says, okay, the air is going to go from the corridor to the room, from the room straight up to the thing. Some will show curvy arrows. It comes in the door, past the patient, and then up. That's a super good ventilation system. But how many people have trained the air to follow the arrows? Not too many. So we really need to make sure we understand how the room goes. And then, yes, we'll get higher technology, and we'll use your lighter or smoke or tissue or something to see, okay, is the air actually moving in the right way? So we need to talk in future guidelines about, these simple things that you can do for your laugh test. I call it my laugh and cry test. If it passes the smell test, okay, I'll say, okay, we'll move on. Doesn't mean I won't check the ventilation. But if it fails the smell test, I'll cry and say, we need to do something now. Take a look at this one. Smoke's going out, right? You'll hear me say something, and then it stops going out. So this is actually from a country in Africa where they put a fan in a window. And the smoke was going out for a while, then it stopped going out. What happened? Somebody says the wind outside shift. Any other ideas? Power. No. What? Okay. Well, what actually happened here was the door was nearly hermetically sealed. So when the door was open about 3 inches, air would go from the corridor through the room and out. When they closed the door, the fan would just go round and round and round. So when we talk about ventilation, we need to say, okay, where's the air coming from? If it's not coming from anywhere, you're not going to pull or push air anywhere. So we need to make sure we understand the movement of air. Here's a relatively complex, this is not University of Florida in Gainesville. But this is a BSL-3 lab. They have a computer monitor for everything, the fan, the pressures, and whatnot. And he's looking at it to make sure nothing changes. Nothing was changing. So we went inside. What is this? Lab people? Yeah, that's a midget machine. And on the left here is a Class 2 B2 cabinet, biosafety cabinet. That's what they'll do the work or manipulation of the samples in. They gave me a stack of paper literally that thick in a booklet. saying this was tested, everything was working perfectly. So what I did was I took a simple smoke tube, and this is what we found. Whoop! And we'll do it a second time just to make sure. What do you think? Do you want to work in that lab? Hey, Chuck, this definitely isn't your lab, right? No. But what we need to do is we need to empower workers to use a piece of tissue or something every day before they use a hood to say, okay, is the air going in? And is that tissue or a piece of paper or something angled about the same every day? And if it's not, then there's a problem and you do something. So we have to essentially get the people, the workers, the staff, to enough knowledge so that they can go and say, okay, Mr. Facility guy or Mr. Engineer or Mrs. Engineer, it's not working, fix it. And they'll say, well, you're not an engineer. Well, you can say, well, I see air going from the cabinet into my face. And then you can say, okay, I know you're not a microbiologist, but would you like to work here? I will aerosolize some stuff and you can test it. And then I think you'll see they'll come running and check it out and fix it. Now here's a room. We did the old tissue test on the door and it wasn't working. We did the tissue test on the grill and it wasn't working. So what's the problem? All the other rooms were working fine. The company that did the testing and balancing showed that, yes, there was air going from the corridor to that room all the time. But in reality, it wasn't. So what's wrong? How would you like a duct like that? Essentially, it was blocked and dirty, and it's not so nice. Can you tell I like labs? This is the last lab picture. But here's a lab. Here's a class 1 biosafety cabinet, and here's the exhaust. So it was designed to take some room air plus all the air from the cabinet. It's actually a good design. Which way is the air blowing? Could you see the little tape there? It was blowing into the room. Why is it blowing into the room? Because there was actually no fan connected. And people never checked it. So this is why we have to make sure people have the power to look at things and check them. Now, we already sort of got part of this answer, but periodic checks for negative pressure. There are many, many labs that have, and healthcare facilities that have all these, hundreds of thousands, if not millions of dollars of monitoring equipment. Why do the CDC guidelines talk about testing each room every day with a physical device, smoke or something else? There are a couple of reasons. One is, in the late 80s, early 90s, there were 3 major studies in the US that showed that fewer than 50% of the airborne infection isolation rooms were working properly, even though the electronic devices said that they were. Because electronic devices are what? You can tweak the alarms, they may go out of calibration, there are all kinds of things that can happen. So generally, we do not recommend only reliance on the alarms. Now I'm going to talk about a few devices other than smoke that you can use. Let's see. Oh, not yet. Okay. If they're not being used, but could potentially be used, just check them now and then. And laboratories should be checked daily. This is a CDC lab. It's one of the newer ones. My wife works in the VZV lab in this floor. What kind of ventilation system do you think they have? Top end? Top end, top end. All kinds of monitors and whatnot. This is the door to her lab. Can you see what that is? Here, I'll do a blow-up of it. What is that? How many people are old enough to know what a video or an audio cassette tape is? Well, she's actually standing inside the lab, but before they go into the lab, they don't look at all the alarms and everything else. They look up and see, is that tape going in? And is it going in strongly? If the answer is yes, they go into the lab. If the answer is no, they make sure that the facility people know that it's not working properly. So what I'm recommending is not just because it's a TB facility or an isolation room or something like that. This is what we at CDC do for normal practice because we don't always feel 100% confident on electronic controls. What's this guy doing? He's ambidextrous. He's got a smoke tube in his left hand and a venometer in his right hand. So he's just checking to see if this room is positive or negative relative to the corridor. Does everybody know what a venometer is? No! It's my favorite toy. And I'll show you why. So here's a venometer. Here's a door. A venometer is essentially a piece of plastic that has a not super precise, but sort of a constant sized opening. How many people remember video cassette tapes? Well, it essentially has a piece of video cassette tape with a pin through it. So if you blow on it, it would move this way. So which way is the air moving here? Is it moving from the door into the room or from the room outside? It's moving from the door. It's the air underneath the crack is pushing the vein into the room. So that's saying the room is negative pressure relative to the corridor. So now I'm lying on the floor, which I don't recommend. But what do you see now? Which way is the air moving? This is the same room, maybe a minute or two later. It's going out of the room. And now what is it doing? It's neutral. Well, we actually measured the supply and exhaust mechanical ventilation. It was perfect. So what's happening here? Somebody opened a window. So if something as simple as opening a window can cause your pressures not to be proper. So just a little gust of wind against a building can pressurize that room and send that air into the corridor. So we really have to make sure, if you do have mechanical ventilation, that we emphasize the importance of making sure that all conditions are met. It may mean, somebody on the ward or the floor needs to maybe multiple times a day go around if they have openable windows and make sure they're closed. Maybe that's something they can do when they go around and do their check for negative pressure. Here's one of those devices. It's about $40 piece of plastic. And how many people have 40 cents in their pocket? Anybody? Nobody. Oh, but this is a poor state. Boy, I've been in countries that have more than 40 cents in their pocket. But for 40 cents, you can make your own. So the idea is, it's not really a difficult device, but it gives you an approximation of airspeed. It tells you direction. It's kind of a neat little toy. Let's talk about UVGI. This was supposed to be animated, but I guess I goofed. UVGI stands for ultraviolet germicidal irradiation. There's a group that's trying to change the name to germicidal ultraviolet because they think the word irradiation scares people. Right? How about MRI? What was MRI called before it was called MRI? Nuclear magnetic resonance imaging. And they dropped the nuclear because it scared people. I don't want to get irradiated, bombarded with nuclear stuff. So it's really an imaging thing. So you may hear this new term or see it. I think the next set of guidelines will have both, because I'm not ready to give up on the original term. Okay, when we talk about UVGI, it's inherently unsafe. Does that scare you? Well, it should a little bit, but I don't mean to scare you. But what we can do is we can make it safe by doing a number of things. We can get a good fixture design, so it's not shining into the occupied space. We can make sure we have a good room design, that we have it located so you don't have reflection off of chandeliers and TVs and other things. We need to make sure it's installed properly, that it's parallel to the floor and perpendicular to the floor. Because if you have a unit that may be perfectly designed and it's hung like this, how effective is it? It's super effective, but you're going to get high levels of UV in the occupied space. And then proper commissioning, take measurements. Does it actually have a UV lamp inside? Does it have a germicidal UV lamp inside? Or does it just have a blue lamp inside? Because there's a difference. And then the last thing is make sure we understand what's required for ongoing maintenance and monitoring. By monitoring, we need to make sure we have a meter that measures the germicidal wavelength. If you take a look in the internet, use good old Mr. Google, if you type in UV meter, you're going to find all kinds of UV meters. But one of the more expensive ones are the ones that have the filter to only measure germicidal wavelength. Because we don't want to measure visible. We don't want to measure UVA or UVB. We want to measure the UVC wavelengths, in particular the germicidal wavelengths within UVC. When we take a look at low pressure mercury lamps, which are the standard lamps, they put out UV at 254 nanometers. The maximum efficiency for UV in inactivating organisms is around 270 nanometers. But you can make very cost-effective lamps with mercury vapor that are 254, which is close. Now that LEDs are being developed, they're not quite ready for prime time for UV, but they are for commercial and residential lighting. But someday we're going to see germicidal LEDs that are at the 270 wavelength, so we'll actually need less UV in the room because it's more effective at inactivating the organisms. But we need those fixtures that are designed well, that we get a lot of UV in the upper room and very little in the occupied space. The other question I get a lot is UV effective? Sometimes I say it depends. Sometimes I say yes if. And in this case, if we take a look at a study by Richard Riley in 1970, that was published in 76, he took a bare bulb, a germicidal lamp, in his office, aerosolized BCG, wore a respirator and protective gear, and he got the equivalent of 10 air changes per hour in his office. Is that good or not so good? That's good. It's not very expensive. If we take a look at Rod Escom in Peru, he did a study where he had TB, HIV patients, did something similar to the air facility where he took air from those patient rooms, sent it to the guinea pig colonies, and he found about an 80% efficacy with upper room UV. He didn't, in his paper, talk about air changes per hour or anything like that. It was somewhat limited information in the paper, but it's pretty good efficacy. At the air facility, we did a similar study, and we found similar results. We got 80% efficacy. So it helps support Rod's data. But what we also did was we took a look at air changes per hour. We were taking the equivalent of 6 air changes per hour out of the room, sending it to guinea pigs. The UV in that room gave us the equivalent of 24 additional air changes per hour. So what does that mean? It means if these fixtures are not properly maintained, we'll still probably always get 12. If they're maintained, we're going to have phenomenal killing or inactivation of what's airborne. But when we take a look at dosing, how much UV do we need in a room? If we take a look at Riley's recommendation, it's 30 nominal watts per 200 square feet. Essentially, a 30-watt bulb in his office that was 200 square feet. That's how that came about. If we take a look at a study from University of Colorado, what they did was they put UV in the room and aerosolized organisms, measured decay, and they measured UV in the upper room. And when they measured essentially an average irradiance, depending on the study, of 30 to 50 microwatts per square centimeter. And that became a guideline for a while. But this requires for every single room, you have to do a lot of measurements to figure out how much UV is in the room. And at the air facility, we took a look at how much UV is actually coming out of these fixtures and came up with a dosing criteria based on volume and output. So if we take a look at, I'm just going to jump to metric. If we take a look at 15 to 20 milliwatts output per cubic meter, you would get the equivalent inactivation or killing as you did in what? The study in South Africa. So we're actually working on, hopefully start in 2 weeks, a dose about 75% of that to see, okay, what efficacy do we get at a second point. So this is one data point. We don't know what the curve actually looks like. I told you I'd talk about displacement ventilation. If you take a look at the beaker on the left, dilution ventilation is you throw some stuff in, you take a little bit out, and everything is mixed. So if you have a cup of coffee and you're slowly adding water to it and allowing it to drain out the top, it'll get lighter and lighter and lighter and eventually look clear. But it'll probably take you a few pitchers of water to do that. With displacement ventilation, what you're doing is you're putting air in at the floor level and essentially allowing it to rise to the exhaust in the ceiling. So when you hear the term displacement or vertical ventilation or vertical plug flow, this is what we're talking about. This is actually a study that was done here in California. And we've got air coming into these diffusers from the supply. It was originally built with ceiling supply and exhaust. And we're taking a look at how effective is it. So we put smoke in the air supply, so you can see this is the cooling cycle. Air is coming in, and what happens over time? It spreads out, cool air warms, and what happens? It rises. And you can see it's just about to rise. And after a couple minutes, the whole room is full of smoke. Now, this is not cigarette smoke. It's disco smoke. But what about the heating season? When we talk about displacement ventilation, we talk about sending in cool air and allowing it to rise. People say, well, what happens when you have to heat the air? Well, actually, the same thing happens. If you send air in, what's going to happen to it? It may cool a little bit, but it's warmer than the natural environment, so it's going to rise. So whether it's a heating season or cooling season, you're going to get good air exchange. It's not quite as good in the heating season as the cooling season. But what you'll find is with the exhaust high and using equivalent mechanical ventilation, you'll get essentially, the results will be equivalent if you have the equivalency of 4 air changes per hour of displacement versus 6 of mechanical. So what does that mean? You have to heat and cool less air. You can have more efficient clearing of the air in the room. Let's talk about respiratory protection for a moment. How many people know what 42 CFR 84 is? Nobody? Oh, man. It's actually the U.S. regulations for respirators. And what's my first bullet? Confusion. People don't know what it means. There's a filter designation there. N, R, and P. What does N mean? No? Non-oil. Very good. What does R mean? Oil resistant. What does P mean? Oil proof. So there are different standards for oil. How much oil is aerosolized in a healthcare facility? Industrial environments, you'd probably be concerned about something other than N, but at a healthcare facility, N is probably fine. The other thing is you've got 95, 99, 100. What does 95 mean? It's the filter, not the respirator. The filter is 95% efficient at removing 0.3 micrometer particles. What does 99 mean? It's 99% efficient at removing 0.3 micrometer particles. What does 100 mean? No! 99.97. What did my grandmother tell me? Nothing's ever 100%. But the official definition is 99.97, which you can round up to 100. And they didn't want to call it a 99.97 respirator. Well, I'll get to that, please. Type of respirator. Okay, there are two terms used, and it's kind of confusing because they use both terms in the regulations. It's just disposable respirator and filtering facepiece respirator. What does that mean? It's essentially you're putting the filter on your face. And disposable means you can throw it out. How often do you dispose of a disposable respirator? There are too many salespeople that have talked to you. If you take a look at OSHA, I haven't looked at the Cal OSHA website, but if you take a look at OSHA and you take a look at NIOSH, they say to replace it when not necessarily just wet, but non-hygienic, increased resistance, or the appearance of damage. So when I travel, I always carry 2 respirators. One is because I perspire a lot, so I'll use one in the morning, I'll use one in the afternoon, and then the next day I'll use the same respirator in the morning, same one in the afternoon. So I'll use it a few times. Because I know I've been fit tested so many times, I'll still pass. What's a PAPR? Right, a powered air purifying respirator. And I'll talk about those in a couple minutes. What's APF? Is there an OSHA person here? No. Assigned protection factor. What that means is they've been tested and classified. So a disposable filtering facepiece has an assigned protection factor of 10. What that means is if you've been fit tested and passed, that you're reasonably assured of a 10-fold reduction in what gets inside the respirator. So if you have an N95, the filter is 5% leakage, and the face seal is 5% leakage. So that's why, when we take a look at N95, it doesn't mean it's 95% effective on you. With a proper fit test, it would be like 90% effective. Let's talk about a P100 respirator. What's a P100 respirator? It's oil-proof, and it's 99.97% effective at 0.3 micrometer particles. Is that better than an N95? Oh, man. See, we need to clarify this. The assigned protection factor for a P100 is the same. If you breathe through a HEPA filter, you get a lot more resistance. So what happens to leakage around the face? You get a lot more leakage around the face. So to go from an N95 to an N99 to an N100 or a P100, you're not really increasing the protection to you. So we need to make sure people understand that. That's one of my pet peeves. Are there other standards? Yes, there are other standards. Europe has probably the best standard in the world. Now, I didn't say that. But when I travel, I use European certified respirators. And I'll explain why in a minute. And the CEN standard, CEN standard is Central European norm. Most of those are becoming ISO standards. So you'll see sort of a transition from EN 149 to, I forget what the ISO number is for respirators. But these respirators are tested against oil and non-oil. So you don't have to worry about NR and P. They're tested against both. They have 3 levels, 1, 2, and 3. Forget about 1, because 1 are like 80% efficient. 2's the filter are 94% filtration efficiency. Is there much difference between 94 and 95? No. How about level 3s? Level 3s are 99%. So they're a little more efficient filters. But what's different between the US standard and the European standard? The European standard, the respirators are tested on people to make sure they fit. If you take a look at the list of certified, I can't do this. How do I do this? Here we go. Certified N95 respirators, the list is this long. If you take a look at the European certified respirators, the list is this long. Why is there a difference? Because a lot of the US respirators will not fit people. There's one, I was telling Lisa last night, there's one respirator that Chris Coffey tested among 21 N95 filtering face piece respirators that did not fit a single person in his study. But it was certified. So that's one reason why I will take a look at European respirators when possible. And there are a few European respirators that are also N95s. So those are the ones that, if I were making a recommendation, which I can't recommend a certain brand or model, I would take a look and see, okay, what's certified by US standards and by European standards, and use those respirators. So what do we do when there's a shortage of respirators? How many were here when SARS was around or when H1N1? Did you have troubles getting N95s? So what you have to do is you have to negotiate with your Cal OSHA person and say, okay, I can't get N95s. Here's the data for the European respirators. Please, please, please allow us to use them, because it's a choice of them or nothing. And you'll find that it actually provides better protection. But that's not official CDC policy. What's the difference between respirators and masks? So I'm checking my time. I only have 100 slides to go. What's the difference between respirators and masks? Masks are better. They're better for what? Okay, a respirator is designed to protect the wearer from small particles. A mask is designed to protect the environment or the patient from large particles and protect the wearer from large particles. So when you see respiratory protection, masks are a type of respiratory protection, though some people don't think they are. Don't classify them as a type of respiratory protection. Here we go. What do you see here? She's double protected. Good or not so good? No. And what does that surgical mask do? It makes a problem with the fit of the respirator. So don't do that. How about this? Is she ready to go into a TB isolation room? No? Ha ha! Gotcha. So if you're dealing with a patient that may have influenza and you want to reuse the respirator, or you want to, you can very easily take off the surgical mask and then dispose of the respirator, you can do something like this. This does not violate fit or anything. So which respirator should you use? The one that fits you and that you pass the fit test on. Right. So as far as an N95 or P100, which is better? I hear it's the same, and it depends on where you work. Okay. You'll get the equivalent protection from either one. Oh, I'm sorry. I was thinking healthcare. Yeah, if you're working in a paint factory, you would not use an N95 or an N100 or a P100 because they're vapors. So that's sort of an additional issue. If it were only an oil aerosol, then yes, you could probably use a P95. But in a healthcare setting, generally you pick an N95 because it's cheaper and it provides a good level of protection. But it's only 90%, could be higher, but it's, again, better than nothing. Powered air purifying respirator. This is where the respirator regulations get goofy. Okay? The PAPRs have high efficiency filters, which are different than HEPA filters. So when you're wearing a PAPR, you may think, oh, I'm essentially getting HEPA filtered air. Well, you're not. You're getting probably equivalent of 99 to 99.5%. So it's very good filtration, but it's not perfect. So which respirator should I use? It depends. Based the selection on risk. Keep in mind sustainability. That means, if you have a 3M PAPR, can you get 3M parts here? Or MSA or some other company? Let's talk about a couple of pros and cons. Disposable filtering face piece respirators. They're lightweight. Some people don't think they're comfortable. I think they're good. You get good protection if you have a good fit. And they're relatively inexpensive. The cons are for you men with beards and stuff. I won't pick on Chuck. But you can't wear a filtering face piece respirator, or else if you do, you're not going to be assured any kind of fit. Face seal is questionable. Why? Because you have a filter, and some people that wear the duckbill filters, the crease just doesn't seal against the face. Some people it does. Glasses may interfere. What's an elastomeric respirator? Sort of the rubber mask or rubber face piece respirator. And what you're going to find with those is you'll generally get a better fit than a filtering face piece respirator. I find they're comfortable, except for in very warm environments. The life cycle cost is good. You may pay $50 for the face piece, but then the filters you can use for a long, long period of time. Negative is the same thing about facial hair. It's a little heavy, a little harder to talk, and glasses may interfere. With PAPRs, You can have facial hair, you can wear glasses, generally. Comfortable, you get a little cooling effect. Life cycle cost is okay. There's several $100s in the beginning, but again, you don't have to buy a $5 respirator every time you need one. But the cons are the high initial cost, high maintenance, and they provide zero protection when the batteries die. And I don't mean to talk negatively, but in 9/11/2001, what happened? Police went to their trunks. They pulled out their PAPRs because they were prepared. How many of those PAPRs do you think worked? Almost none. And it's because there wasn't a proper maintenance program for the batteries. And the batteries were old and whatnot. So what's going to happen in your facility? Are you going to have the program for maintaining the batteries? If yes, and the risk dictates it, go ahead and use it. If you can't maintain batteries, you're going to create a worse situation by having PAPRs. Just a couple miscellaneous topics. Sometimes you go to places and say there's one simple solution. They say, all we need is a new building. How many of you have thought that? Oh, man. All we need is ventilation. All we need are respirators. And I'm not going to do anything because there really isn't a problem. I'm already infected. And these are real cases. It'll have no impact. Why do they say it'll have no impact? Because people are not measuring. And lastly, there are no resources. So scratch that. And there are a couple NGOs here, and this isn't just for you. I don't mean to embarrass you. But what happens occasionally in facilities is they'll say, okay, at the end of the year, we have an extra $100,000. So what do? You go buy something. And was there planning for sustainability? Probably not. Was there planning for training? Was there funding past the time of that initial slug of money? What about maintenance operating costs? So even though I'm talking about some international observations, it still happens here. And then the last thing is TB, infection prevention control, a global priority? Yes, no, or maybe? It should be, sort of. So let's take a look. I'm going to talk about global and not national, regional, or local. But we also have to remember when we're talking about it, it's not just healthcare settings. It's prisons, it's communities, it's military, it's many, many places beyond just the healthcare facility. What is this? It's a homeless shelter in St. Louis. What are they doing? They're putting in upper room UV. Is that going to be effective? Right, so what we have to think about is, yes, UV can be effective, but it has to work in synergy with the room. Are you going to get good air mixing from the lower bunks up and from the clean air down? Probably not. So we have to take a look at solutions, and are these appropriate solutions? Now, I've never been able to take a picture at a U.S. prison, but I got one in Russia. But don't forget the prisons. I know there are three guys here, right? They were at lunch. Oh, man, they skipped out. So when we take a look at NTB strategy, the goal is a world free of TB, but they have three pillars. On pillar 2, which is really bold policies, they've got infection control mentioned. When we take a look at the three pillars, the left one is integrated patient-centered care, bold policies, and the last one is intensified research. What we need to do is emphasize infection prevention and control in all of these aspects. So from the standpoint of global, yes, they're at least talking about it, but we need to integrate it into everything. So I've got two take-home messages for you. First is, remember, with all levels of hierarchy, there are administrative controls involved. So when you go beyond just the basic implementation measures or control measures, we'll put engineering or environmental measures with administrative controls, and then put our respiratory protection with administrative controls. We're really dealing with a package of measures and a plan for sustainability. And the last thing we have to remember is that TB IPC is a continuing process, so it's really a spiral. How many people here are pessimists? Okay, so here the spiral is going down. How many are optimists? The spiral is going up. But we have to just continue through the cycle. And my friend Lisa, when we were in Tanzania, started calling me Buddy. And I need to show you why she calls me Buddy. Keep watching. That was Buddy the Elf and Dolly. And we were in this parade, and you can see everybody's in a perfect line, except for one car. That's my wife laughing. So anyway, thank you. I know I went over.